have got three presenters today. Up first, I believe, will be Jean-Yves Lauture. He's our CTO at EOS Positioning Systems. And then we're going to have Eric Gaxatter. He's a technical consultant who's going to speak to the benefits of having 4 constellations. And we've also got with us Jeff Shaner, who is in charge of Esri Mobile Apps. So we hope you enjoy, and definitely stick around, ask us some questions, and if you haven't come down to the booth in the expo hall yet, we encourage you to do so and get a hands-on demo. So thank you so much, and I will give this over to Jean-Yves.
Happy to have you here and to host you here, and thank you for being present. The flow of the presentation today is going to be about, first of all, for those who don't know EOS, who is EOS, what we do, what do we do. And also we're going to come in with some subject, some topic that are of high interest on GNSS, on GPS, is what is the status of the GPS today? We talk about GNSS, multi-constellation, so we're going to cover that also. And then we're going to keep on going on with a few solutions that EOS has come up since last year to empower collector a little bit, to do things that collector doesn't do, like laser offset and other things. And also, we also have with us Jeff, as Sarah mentioned, Jeff Shaner, who's going to talk to you also about what has been done lately in Esri Mobile Apps Collector, a new version of Collector, and what is to come also in their roadmap. So for those of you who don't know EOS, EOS builds and manufactures GNSS receiver, high accuracy GNSS receivers for mapping applications. The idea behind it was to bring down to 1 centimeter accuracy to people who know nothing about GPS, who are not surveyors, but still want that high accuracy into their mapping. And it was a difficult task over the years, we can say, because we kind of pioneered, our technical team pioneers for years, first having the first Bluetooth receiver on the market back in 2001, and then having the first iOS-compatible receivers also on the market. And I remember the old days with Jeff back in 2014 when the GNSS metadata was being added to Collector. The RO200 was the first iOS RTK-compatible receiver on the market. And fortunate enough that the timing was perfect with Esri, so they could develop and add on metadata into the mobile applications. We have various models ranging from sub-meter down to 1 centimeter accuracy using RTK. We're going to start first with the GNSS constellation status. As of today, we can look at the number of satellites that we have available. We were used to talk about GPS, but now we talk about GPS, the American constellation, GLONASS, the Russian constellation. We have Galileo, the new European constellation that has come on very, very strong, with a lot of aggressive launches over the past 2 years for us to have today an almost complete constellation of GPS, of Galileo satellites. And we also have Beidou, which is a Chinese constellation, which is partly regional to China and also partly global. So we talk here about the 4 global constellations today, and this adds a total of 128 satellites in orbit around the sky, around the Earth, and then with 98 usable, 128 total, that means orbital and non-orbital, for example, like Beidou, but 98 usable satellites is what we have. And these, briefly, I'm going to be passing on to Eric, but he's going to show you the performance, the reason why more constellations can help today in difficult conditions, because GPS has its limitations, and adding more constellations really help. So, Eric, I'm going to invite you to come up here.
Hey, great to be here. I've touted over the last 10 years the value of more satellites for high accuracy GNSS. In the beginning, I've been in this business for 30 years now, and I used to map a lot of golf courses. Back in the early 2000s, when really it was GPS only, and so I'd go out and I figured out really quick how many irrigation heads are underneath trees, right? And so, anybody else try to RTK underneath trees or use GPS underneath trees, and how you get, sitting there waiting around, right? And so, and at that time, I was doing centimeter accuracy locating sprinkler heads for as-builts for golf courses. And I would just struggle. I would just be hanging around trees and just waiting for enough satellites. You'd be struggling with 5 or 6 at a time. And at the time, I knew once, and then then GLONASS kicked in, and that kind of helped out, right, with productivity. And now there's this next phase of the Chinese and the European satellites that are really helping us a lot. And it's changed dramatically even in the last year. I gave a similar talk about a year ago. And since then, China has launched 18 satellites, right? And it really helps us out from a high accuracy standpoint. And this is one of the mantras I talk about in the presentations I give. And actually, it's more aggressive now, I think. I used to say this a couple of years ago. GNSS technology is going to change more in the next 3 years than it has in the last 15. And I'm going to venture to say it's going to change more in the next 2 years than it has in the last 20 years, okay? And the reason is because there's more satellites. And so just a few acronyms and definitions to get out of the way here so we sort of on the same page. So GPS is the EOS constellation. That was sort of the gold standard out there. There's 31 satellites in orbit. Pretty consistent. Whenever they launch a new one, they have to take one out of service because the ground infrastructure can only manage to handle 31 right now. GLONASS is the Russian version of GPS, was designed or developed around the same time, and then it took a nosedive in the end of 1990s because of the political instability there. But then it's kind of built back up, but it's stable now at about 24 satellites orbiting the Earth globally. The last two are the wild cards, right? So Galileo it's the only system of the 4 that are civilly funded. The other 3 are funded primarily by the military. But the Galileo system is civilly funded by 27 member countries of Europe. It's really taken off, and they're launching about 4 a year. There's 22 in orbit right now. And they'll finish off their constellation this year and next year, but the satellites are usable now, okay? And like I mentioned, Beidou has sort of gone from 0 to hero here in the last 2 years. And a couple more glossary things here. So when I throw these acronyms out, I want to make sure we hit the definitions right. So RTK is centimeter accuracy in real time, okay? So centimeter accuracy, GNSS in real time, in the field, okay? RTK base station is, with high accuracy GNSS, you have to have access to a base station of some kind. Doesn't have to be next door. It could be 30 miles away, or it could be a network in your state. And actually, half the states in the U.S. have RTK networks that have free access to them, okay? But anyway, so you have to, when I talk about RTK base stations or RTK networks, that's infrastructure that's set up in an office building somewhere that's collecting data and connected to the internet and is able to send data to you in the field. This is kind of a cool slide that is from UNAVCO. And just to give you an idea, okay, we talk about stuff orbiting the Earth, these GNSS satellites orbiting the Earth. And, people ask sometimes, well, why don't GPS satellites crash into GLONASS satellites? And there's people a lot smarter than me that know how to manage those kind of systems. But this really gives you a good idea of, you think about, look at the orbit of the Hubble. It's minute orbit in terms of the distance from the Earth, the surface of the Earth compared to GNSS. So just to give you an idea of scale, the GNSS satellites are about 12,000 miles in outer space, okay? And just one other note there, it's amazing to me, this technology still, is that 12,000 miles in outer space, and they broadcast a signal strength of about a 50-watt light bulb. This kind of stuff here. It's amazingly weak signal. So that causes some problems, right? And that's the problems we have when we go next to trees, next to buildings, because the satellite signal is weak, and it can be blocked by your body. It can be blocked by buildings. It can be blocked by trees, and so on. And so the more satellites you have for high accuracy, the more access you have, the better you are. So I've been talking about 4 satellites for 4 constellations for a lot of years, and how much benefit there'll be to having 4 constellations. But that's all just talk, right? That's all just theory until you actually test it. So fall of last year, I set up a test course near my office, and we went through, it takes a lot of work to do this. So it's kind of hard to see, but we've got about 22 control points underneath heavy tree canopy, out in the open of this park, underneath medium tree canopy, light tree canopy, and so on. And I really wanted to understand, if I ran 4 constellation receivers through this test course, how much better can it be if I'm just using 2 constellations or 1 constellation? So we had it surveyed. I actually had an intern, a master's student intern, come up and lay out the test course with Leica Robotic Total Station and went through it and adjusted all the points and ran them through Opus and really got them tied down reasonably tight. And you really have to do that with points, survey points under tree canopy, because obviously you can't do it with GPS and be reliable with it. And this is kind of a neat thing we did also to characterize the tree canopy around each of these points. We had a camera that had a bird's eye 360 lens. We'd set it on the ground and take pictures straight up, right? So this is a clear, open environment, obviously, of one of the control points that's out in the wide open in the park. This is sort of a light tree canopy, and you can imagine if you're in a park and you've got some small trees around you that you're working with. And this is, again, a pretty benign environment. And then it starts to get a little more hairy. Here's some of the points we set up in moderate tree canopy where you have a complete side of view of the receiver blocked with pretty reasonable sized trees, okay? And again, tree canopy is sort of a subjective term, right? I mean, what's tree canopy in Arizona compared to tree canopy in Pennsylvania, compared to tree canopy in Texas and Oregon? You know, we like to think that, you know, Oregon is the #1 Christmas tree exporter in the U.S., right? So we think we have pretty good sized trees. So anyway, here's a heavy tree canopy, right, where you sort of really don't have a clear view of the sky at all. You've got big diameter trees around you. And these are the nasty ones, right? Anybody ever been in these type of environments? If you've been in forestry, you've probably done it. It's brutal, right? It's frustrating because you're just sitting there waiting for enough satellites to come in and your accuracy to get down to a point that you can accept. And these are really tough environments. And I really wanted to make them, I wanted to make the environment as nasty as possible because I wanted to stress it to the point that GNSS just didn't work, right? So what we did is we took 4 days. This is the first week in January of this year. And there's still lots of foliage because we're in Oregon and foliage kind of never goes away for the most part. We took 4 days. There's about 20 to 22 survey control points. I forget how many. I had 2 crews running. We collected 1,000 points of data. Okay, 1,000 of those 1,000. I had them going round and round. They had them working hard. And I had 4 different receivers set up on this test course. All right, that the crew was running through. One receiver was GPS only. One receiver was GPS GLONASS. One was GPS, Galileo, Beidou, and one was all 4 constellations, okay? We took 30 seconds of data on the control points that were out in the open sky and sort of light canopy, and then 3 minutes of data on the moderate and heavy tree canopy. And the reason we took more in there is because we didn't know how fast it may fix to a centimeter solution, and we didn't want to run out of time before it had a chance to, but then on the flip side, we didn't want to wait there for 20 minutes, and so we sort of picked 3 minutes as sort of a sweet spot to do that. So general conclusions, and we actually have I have a whole day presentation that I do on this whole test. We go through a ton of statistics and all kinds of different things here, but I need to keep it short here. But general conclusions are this, is that there's a 50% and this is not out in the open sky, right? This is under, you know, the heavy and moderate tree canopy. So 50% productivity going from GPS only to GPS plus GLONASS, right? And then another 50% increase going from GPS and GLONASS, which is pretty standard today, to using all 4 constellations. And the only asterisk at the bottom is that since the launch from Galileo and the Chinese are so active, we weren't using the latest 4 Galileo satellites and the latest 8 Beidou satellites. So we can only think that our performance would be better if we ran it again today, which we plan to. So it's not about, what's interesting is that folks ask, well, how much more accurate if I use Galileo or Beidou? And it's not about accuracy. It's all about productivity. It's how long do I have to stand there when I'm next to a bunch of trees or under a bunch of tree canopy to get a centimeter or close to a centimeter position. That's what we're talking about, is productivity. We're not talking about accuracy. Accuracy with 1 constellation versus 4, given that you have a reasonable number of satellites, is really about the same. There's really no accuracy improvement. It's all about productivity. And just to give you examples, so you can look at this. This is an actual receiver that we have running at our office, and you can see GPS using 9, GLONASS 7, Galileo 6, and Beidou 7. And actually, this is using, I'm thinking it's using the latest Beidou as of last week, and then maybe not Galileo. But so this is pretty solid. You think about it, if you got a GPS only, you get about 3 times more satellites than using GPS only. And again, high accuracy is all about getting more data coming in, right, and giving you a faster solution. So just really quick, I mentioned this before, but about half the US states now provide access to free RTK network. Down in California, it's free. It's GPS only, and some GPS GLONASS. Arizona's free. Oregon's free. Colorado's got free areas. The whole Midwest has basically got free coverage except Illinois. That's why people are moving out of Illinois these days. And then down the Southeast too, and in the Northeast somewhat. But about half the states have free RTK networks. Right now, Utah is the only one offering 4 constellations, and it's partly because we have a project down there, and it really pushed them down there because we really thought they could really benefit from it. So, and then Florida and New York offer 3 constellations. The rest are offering either GPS and GLONASS or GPS only. Most commercial RTK networks out there, and I won't speak for all of them because I'll probably have someone yelling at me, but most of them support 2 constellations. Maybe some of them support 3 or even 4. So what that's leading this conversation up to is you have all the RTK networks out there. They're only supporting 1 or 2 or 3 constellations. So a lot of clients that we have are actually setting up their own RTK bases, which is pretty easy to do these days. And why would you do that? Well, one reason is because if you wanted more productivity in the field and you wanted an RTK base that's broadcasting all 4 constellations, okay? The other is it may be too expensive commercially because there's some subscription services, especially up in the Northeast, where they're charging $1,000 a year per receiver. Or down in Texas, they charge $1,000 plus per receiver per year. And if you've got a field crew of 15, you can easily justify setting up your own RTK base. And here's just some entities that we've helped set up RTK bases out there. And just off the top of my head, we've got more than that, but just to give you a quick list of them. And the interesting part about it is when you set up your own base, you can share data. You can support 1,000 users. The data requirements over Verizon or even your LAN aren't too heavy for RTK at all. It's pretty lightweight stuff. And here's what one looks like. This is all baseline. There's different configurations. This is one that we developed with EOS. We use an EOS receiver. The box on the left there is a Verizon Cradlepoint modem. So it's a $40 a month data plan, or you can connect directly to your corporate LAN network and just piggyback off of that. Below that, on the lower right, is it's a little Linux box that runs all the RTK software, base software that we developed. That you can have your own users with passwords and logins and sort of manage it that way. You can remotely manage it. So we have bases. We've had bases even down in South America that we log into from Oregon to help manage them. And then we set up monitoring. So if it goes down or the internet is interrupted, it sends a message out via text and email and that sort of thing. So that's all I got. Any questions? I don't want to take up too much time here because there's other people who have to talk. There's my contact info. Follow me on Twitter. Great, thanks.
As Eric mentioned, results are mainly in productivity, but also some other benefits of having multi-constellation is that it allows you to go to very long distances with your base station, what they call a baseline, distance between the rover in the field doing the work and the base station. And typically, receivers are supposed to be within, let's say, 20 miles of your base station. In the case of the Arrow Gold, for example, the normal baseline is about 50. That's what we tell people not to exceed, because it's about 1 centimeter, 50 kilometers. It's about 1 centimeter error per 10 kilometer distance, baseline distance. But using more satellites also allows you to have a better long-range baseline. I mean, what they call the long-range RTK. So we've done testing all the way up to about 80 miles and more, and still getting below 10 centimeter accuracy. So the benefits are there, and we're going to see it growing in the future. EOS, as I mentioned before, EOS also provides unique solutions for Collector. We know the powerful tool that Collector is today, but Collector doesn't go into specific type of applications. And this is where we come into play with offering solutions. One that we offered late last year is highly in demand was the recording of orthometric heights following a geoid model. In the US, it's the geoid 12B, which is part of the NAVD88 datum, vertical datum. So Collector does not yet have this function of supporting geoid models, so we decided to do it. And our receivers now are able to export very accurate autometric height. And with the new version of Collector, the 18.1.0 or whatever, the latest one available on the App Store, not Collector Classic, but Collector that used to be called Aurora in the beta phase. The new version of Collector now supports the Z value as part of the geometry. So you're able to store directly in the field autometric height in Collector and other Esri mobile apps. Also, last year, the UC, we had announced some tools, another solution for Collector, which is laser mapping on iOS. Yes, we have multi-constellation right now, but sometimes you really need that accuracy on the canopy. There are various types of applications where the assets that you want to map are not accessible. We had a nice case study that is published in ArcGIS, the centerfold of ArcGIS with the Woodland Park Zoo. And you really don't want to go in a cage, a lion cage or bear in order to map assets that you have there. So they prefer to stay outside. But then using a laser rangefinder, just like, hold on a second. Just like a very simple setup like this, when we have the receiver and you have a laser rangefinder from LTI, allows you to take point from afar and still maintain your accuracy. And there's also another setup that will look. So that is displayed on the right here. It's a total station type of setup where you have an encoder, people who require really accurate angle measurements. You can do 1 point and then calibrate your encoder and then just map, just like a total station. But what we did is basically simplifying a surveying technique that can be easily used by GIS people who don't know anything about the system. So all this information is sent to Collector also. So this is RTK data where RTK doesn't work. So remote places, highway measurements, you can map panels on a highway without having to go there. When you need to map valves within a street intersection, they don't have to block the road for you to map them. So a whole bunch of applications where the laser can be very useful. Very affordable, very easy to use, and does the job. So one of the methods is a standard laser offset where you have a position, you enter a distance, an azimuth, and a slope, and it computes the point, which is remote. The other one is the range backside. You define a backside point. You record a control point where you're going to be making all your measurements. You calibrate your encoder with the backside so it gets where north is, and then you're able to map multiple assets afterwards. But that requires a little tripod like this. And the other one is the range. When you want to carry this setup, you can take 1 point, shoot that asset, a second GPS point, shoot that same asset, gives you an intersection, and you choose the proper point to maintain. Very easy to use again, and seamlessly transfers everything to Collector right in the field, along with all the metadata. Something else that we're working on right now, probably available and about a month from now, is again an interface for Collector to bring underground mapping, subsurface mapping into Collector directly. Okay, the first model that we're going to be supporting is a Vivax Metrotech Vlog 3 as a sample of a locator. So the idea is to be able to locate and map at the same time. For initial design, I would say, not design, but initial mapping to know where the assets are. So the interface, as you can see here, will be called by Collector, and you will be able to record every single piece of information coming from your locator, including the frequency, the depth below cover. We will be measuring the height at the ground level and the type of locate that was used. And everything is transferred along with all the metadata is transferred to Collector also. And then there's a fully automated mode and there's a semi-automated or fully manual mode also. So watch for this to come out for those of you who are interested. If we're going to try to support the major models in the field. But also rely on you, our users, to tell us what you're using and if this is of interest for you. And other things that we're doing for existing users who know we're using EOS is we're revamping the app also in the next few months, so stay tuned for that. The iOS, Android, and Windows have a new user interface. Also coming up very soon with a Windows version of EOS Tools Pro that will replace EOS GNSS tools eventually, but a tablet version of EOS Tools Pro for Windows. And other things that we will be coming up with are more solutions again for collector. For example, one of them in the SKU would be a point stakeout for people who want to go to the point, stake out the point from a design, and be able to compute cut and fill volumes that will seamlessly be transferred into collector also. So at this point, I will leave presentation to Jeff, who will talk a little bit more about collector and other Esri mobile apps.
First, I'd just like to say thank you, everyone, for kind of being those pioneers into field operations and using mapping technology outside of the office. You might not realize it, but you are at the tip of the spear, and you are the people in your organizations that are really bringing a new evolution to Esri's GIS technology as a whole. And I really want to thank you for all the work you're doing. Within our group, our field operations team, we're looking at the patterns of development of mobile solutions within your organizations. And the way that we think about it is through the context of the activities that you perform. And we're building out a suite of mobile solutions to kind of fit the need. It's challenging for us to build a suite of apps that work across all the different sectors, anything from emergency management to, I talked to someone today that's using Collector to capture pythons in the Everglades. This is crazy stuff. So we look at the ways that you work, and we try to build new capabilities and new apps to support that workflow. And we really do that by receiving the feedback from all of you. I wanted to focus in on the data capture aspects, and we now have 3 products for field data collection as part of our suite. And the first one that Jean-Yves has been talking about a lot is our most mature product that's out in the market right now, and that's Collector. How many of you here today are using Collector? Wow, that's awesome. Most of you are using it. The rest of you, you should feel like, why am I not using Collector yet, right? All these people are using Collector. So Collector has been primarily used for asset data collection and maintenance workflows where you are in charge of the maps and the data models, and that just comes to life by you putting that sweat equity into building out robust data models as part of what you do in your GIS system. And then we've been taking Collector and extending it with capabilities like integration with GNSS receivers from organizations like EOS. And Collector, as you might have noticed from most of you that are here using it today, has been going through this evolution. And it's continuing to go through an evolution. We've basically replaced the engine that's underneath it. We've got a new body style to Collector, a whole bunch of new dials and features in it, and we're going to continually add to that. And we released the iOS version of that new application late last year, and the Android version, we have all hands on deck trying to get it done for this fall. One of the things I wanted to mention, since most of you are Collector users out there today, is some of the new stuff that's come in. We recently released a new version of Collector shortly before the conference. You know, within our development group, we like to just kill ourselves by not only presenting here at the conference, but then trying to ship software right before it. So we're not going to make it past like the age of 55, most of us. My days are almost done. One of the big things that you'll find from the latest iOS version that's out there is that there's over 100 new transformation methods. If you haven't used Collector with a receiver like the EOS Aero receiver, you might not be aware that when you Bluetooth pair it to your smartphone and you're going to use RTK, that you need to establish that transformation between coordinate systems. Or you might not, actually, depending on the map that you make. We actually have a whole session and set of sessions on high accuracy data collection with Collector that I hope maybe you've had the opportunity to take part of. But most of the maps that you author and use in Collector, they're in WGIS 84, and your RTK networks, and at least in North America, are usually in, like NAT 83. So if you want to keep that accuracy, you've got to do datum transformations. We have a whole suite of them now. We also have support for grid-based transformations in the location profile. And you can sideload those grid transformations to your mobile device. We also have, them hosted in ArcGIS Online so they can be downloaded, if you weren't aware of that. Jean-Yves mentioned that we support elevation values in the geometry. Outside of EOS, that elevation value is a height above ellipsoid value, but thanks to Mr. Jean-Yves, you can download an accurate geoid model, and then we'll get the orthometric height and shove it right into the elevation value. And really where we're headed next in that realm is that once the engine underneath Collector supports vertical transformations, then we'll be able to provide that as part of the location profile as well. I think the other big thing that if you're still a classic user of Collector, maybe you're on the Android platform and you're moving to the new Collector, is the user experience. We've done a lot in that realm to improve the way that you use GPS to collect data. When we first built Collector, we really were thinking very map-centric, very much about you tapping on the map to capture data. We've kind of moved to more of a GPS-centric mode of data capture inside of the new application. Some of the stuff that I wanted to mention that's coming next, this last update to Collector added a whole host of new features. How many people here use the Apple platform? A good chunk of you. Anybody sideload base maps? So you'll be excited to know that you don't have to use iTunes anymore. You could actually take your TPKs or your VTPKs, if you want to build vector tile packages, share them into like Google Drive, and then use the Files app on your iPhone to automatically download them and bring them into Collector. Collector is just recognized in the Files app, and off you go. There's a whole new experience for offline that involves taking multiple map areas offline, and you can move forward with that. As I mentioned, we're working hard to get the Android version out. I briefly showed it in our Road Ahead presentation this morning, and our goal is to get that out in Q3. And we're working now on a new design for a back office capability with Collector that will really lower the bar of entry for getting up and running with those web maps, taking aspects like the location profile and all those settings, and giving you an administrative console for pushing them out to your users. And then probably the biggest request out of all of this is to start to roll the smart form capabilities that you perhaps use with Survey 123 today into the rest of the platform. So we've just started on the design experience for that, where as you're authoring a web map and you make a pop-up, you'll be able to make a form. And that form will have conditional logic. We're going to leverage the Arcade expression language. If you haven't learned Arcade yet, it's a great weapon to have in your arsenal, just like Python is. That'll give you the expression logic. We'll have a new user experience for how we bring form controls in and much more. So this is kind of a prototype of some of that new functionality coming in. Look for that to come. The next application I wanted to briefly talk about was Survey 123. Anyone here use Survey 123? Wonderful. So Survey 123 was born from actually Esri getting our butts kicked in the nonprofit space. We were trying to compete with organizations like Open Data Kit and go after, those census style of field data collection workflows where maybe you're you're trying to assess or complete polio vaccinations in Nigeria, right? We need to embrace a standard called XLS forms. We need to provide a solution that hydrated a form in your mobile application, and then it actually wrote that data to a feature service inside of our platform so that we got you stuck in our platform and into the feature service. And so that's how Survey got its start. And then it quickly evolved, right? And a lot of you, I'm sure, don't use it in Nigeria. I'm sure a lot of you use it to do inspections of assets. So we work closely with Jean-Yves and his team to make sure that as you're out doing those inspection workflows with Survey 123, it's also directly supported by the EOS Aero receivers. And the last one I wanted to mention is a new one that we just released at the conference here called ArcGIS Quick Capture. Has anyone heard about it yet? Have you all heard about it? It's a wonderful little application. Knowing that you're mostly collector users, here's the way to think about it. When you make a feature layer, that feature layer has templates, right? The templates really drive the data dictionary inside of collector. Well, those templates can be buttons on a form. And all the default values off of that feature template are just part of the feature that gets created. You don't get a form to enter in attributes. It just automatically creates the feature. And it's optimized for data capture while you're moving. So we've had a lot of organizations like pipeline companies, for example, that want to fly a pipeline right away, or they're walking a pipeline right away, and they want to just mark the violations they see along the way. Perhaps it's brush that's overgrown over top of an asset. They just want to mark that, use the GPS as they're at the location and move along. But it can do much more than that. It can do that, plus it can capture lines. It can capture multiple lines simultaneously if you'd like as well. So I really encourage you to look at Quick Capture. It works well with the EOS receiver as well. It's also been integrated just like Survey 123 and Collector have. And it's an exciting new field data collection app from us as well. That's about all I have. We'll continue to evolve all of these capabilities as we move forward. I think Jack's goal for us is that we have at least 2 new applications a year that we have to build for you. So we'll keep growing and evolving, and I think you're going to see a lot of exciting new development come out of our team in the next couple of years. Thank you, sir.
Thank you very much, Jeff. Just to add on to Quick Capture, that last application, we have a project going on in Canada with the bicycle trail mapping of the province of Quebec. And they were able to, in those type of situations, those of you doing trail mapping, or there's ATV in English, right? ATV. In mapping also, where they need they're going high speed and needing a very high definition. And they were able to absorb 5 positions per second from our receivers, so which is very good. So there's a lot of hope for this small application. I think we toured it all. Those of you have any questions for Eric, Jeff, or myself on the receivers, on Esri's products, on multi-constellation, feel free to ask them now. Yes, sir?
The question was, for those of you who didn't hear it, when you're building your location profile, there are a couple of projections listed for WebMercator, and which is the correct one that you should use. My understanding is I'm going to try to recite the work order or the WKID, and I think it starts with 12. Who knows that off the top of their head? Where's Eric? I think Eric has the WKIDs tattooed on his arm. Yeah, the 102, 100, that's it. Yes.
Any other questions? Well, thank you everybody for being here. Invite you, for those who have not done so yet, invite you to visit our website. Those of you using Collector for a lot of advanced high accuracy data collection, we do have a learning center also with video tutorials, show you how to interface, how to create your profile, for example, with Collector, give you hints and tips depending if you're using WAS, if you're using RTK, how to set it up properly, and how to do autometric height, how to record them in Collector. All these are on our website. Also invite you to subscribe to the newsletter, the monthly newsletter. We get news on the industry, case studies, and drop by our booth number 719. And there's a whole bunch of case studies also available depending on the application, whether it's water. The latest one that came out today was with our friend Mike, sitting right here, Mike George, for a complete laser mapping system. So feel free to drop by and pay us a visit. Thank you for being here, and have a good day.